In this video, we're going to be talking about compound interest. First, let's talk about interest compounded in times per year. To calculate that, we have a formula, A equals P times 1 plus R over N to the NT. A is our final amount, P is our principal, which is our starting amount, R is our rate in decimal form, N is our number of times compounded per year, and T is our time in years. So let's look at our time periods that can be used for this formula. If something is compounded daily, then our N is 365 because daily is 365 times per year. If it's monthly, it's N equals 12, quarterly, N equals 4, semi-annually, N equals 2, and annually, N equals 1. So let's look at an example of compound interest with N times per year. So our example is, suppose $1,000 is deposited by a 20-year-old worker in a retirement fund that pays an annual interest rate of 12%. How much would the worker have when they reach 65 years old? And then a second question, what if the retirement fund paid an interest rate of 12% semi-annually? So let's look at the first part of the question and identify our pertinent pieces of information. So suppose $1,000 is deposited. So that tells me that this is my P because I'm starting with $1,000. So P equals 1,000. By a 20-year-old worker in a retirement fund that pays an annual interest rate of 12%. The next word I pick up in this problem is annual. That means that it happens one time per year, so N is equal to 1. Next, I see that my interest rate is 12%, so my R is going to be 0.12. How much would the worker have when they reach 65 years old? So my T is going to be 45 because a 20-year-old invested and we want to know how much it would be when they were 65 years old. 65 minus 20 is 45. So now I can work this problem. My formula is A equals P times 1 plus R over N raised to the NT. So I have A equals 1,000 times 1 plus 0.12 over 1 to the 1 times 45. And when I put this in my calculator, I get that at age 65, they have $163,987.60. Next, let's look at our second question. It says, what if the fund paid an interest rate of 12% semi-annually? So all of our other information stays the same. Our P is equal to 1,000. Our R is equal to 0.12. Our T is still 45, but our N is now 2 because we're semi-annually. So we get A equals 1,000 times 1 plus 0.12 over 2 to the 2 times 45, which is going to give us $189,464.51. So that's how compound interest works if it's n times per year. Let's look at if the interest is compounded continuously. Our formula for that is A equals P times e to the RT. So our A is the same, that's our final amount. Our P is our principal. E is a special thing in math, just kind of like pi, and that is the natural exponential. And its E is approximately 2.718282. But to solve these problems, generally you'll just use the E key on your calculator, which is second and then ln. Next, R is our rate in decimal form. And T is our time in years. So let's look at an example of interest compounding continuously. In our second example here, we have suppose $2,000 is deposited in a retirement fund that is compounded continuously at a rate of 5%. How much will be in the fund after 25 years? So we know that we have our formula, A equals PE to the RT, because it's compounded continuously. So we're looking for A. We're depositing 2,000, so our P is equal to 2,000. Our rate, R, is equal to 0.05 because it's at a rate of 5%. And our T is going to be 25 because we want to know how much will be in the fund after 25 years. So we have A equals 2,000 E to the 0.05 times 25. So that gives us $6,980.69.